Lesson 76, today we're going to be multiplying and simplifying radical expressions. We've already simplified radical expressions. There was a couple of them in the homework last night. A couple maybe you didn't ask questions about. 5 and 6 were simplifying radicals in lesson 75. Just kind of getting you primed back up to revisit this subject. Today we're going to be multiplying and simplifying radical expressions. We've already covered one of the properties that is in play, but here's an important concept. When you multiply radical expressions, you can only multiply the rational parts times rational parts and the irrational parts times irrational parts. Now here's what that means. If you're multiplying a rational expression, it's okay to multiply the outside parts times each other. It's okay to multiply the parts that are inside, the radicands. We can multiply the radicands times each other. But you can never multiply a number that's on the outside times a number that's on the inside. Okay? That's what we mean by multiplying the rational parts times the rational parts and the irrational parts times the irrational parts. So we can multiply radicands and the numbers in front of the radicands. But you can't multiply them together. Okay? So that's an important, that's the kind of the key to getting off on the right foot with this lesson. All right, let's have a look at an example here. The square root of 8 times the square root of 2. This is very simple, right? What would it be? The square root of 16, because both of those numbers are inside numbers, right? They're irrational. It's okay to multiply these two irrational numbers and get the square root of 16, which then must be simplified as 4. Just 4? Just 4, right. Square root of 16 is 4 and only 4. How many square roots does 16 have? 2. But this is only asking for the positive square root. Yes. All right, what about this one? Here's an example where we have irrational parts and rational parts. Which of these numbers up there is rational? So 6 and 4 are rational. Square root of 2, square root of 3 are irrational. So we're multiplying this expression. It's okay to multiply the rational pieces. So 6 times 4 is 24. Square root of 2 times the square root of 3 is the square root of 6. Can the square root of 6 be simplified? No, because there are no perfect square factors of 6. So that's it. All right? It's okay to leave your number. Now that's an irrational number. Our product is irrational because we don't get rid of the irrational parts by multiplying. Okay? What about this one? What does 6 times the square root of 3 squared mean? Do what? 36 times the square root of 9, right? When we square this, we can multiply 6 times itself and get 36, and we can multiply 3 times itself and get 9. So that will be 6 times, or 36 times 3, which is 108. It's a pretty easy lesson. Okay? 2 times the square root of 6x times the square root of 4x. Any ideas here? All right, now, could we do anything that would make our problem maybe a little easier later?
10 times the square 2 times.
What's the square root of 4? And trust me, this is going to make the process easier. We'll work it the other way in just a second, and you'll see how this is easier. All right, so now we can multiply the 2 by the 2, and that gives me 4 square roots of 6x squared. Is there anything we can do with that?
Take out the x.
We can take out the x. I wish they had told us at the beginning, and there may be in the book, this does tell us that x has to be greater than or equal to 0. I'm hoping that it says that in the textbook, because otherwise we would have to do something special to that x squared to make sure it comes out as a positive value. Because by rule, this has to put out positive numbers. Okay, so 4 square root of x squared is x as long as x is greater than or equal to 0. And we're left with the square root of 6.
If it doesn't say that in the textbook, you're supposed to go ahead and do it.
Yeah, I want you to, we're going to assume that that's the case for now. When you get into Algebra 2 and college algebra, you would have to go with absolute value of x there. Okay, by rule, we have to go absolute value of x because the square root has to be positive, and the absolute value forces it positive. Okay, all right. If you decided to do this a different way, if you decided to just roll with it and multiply this, you get 2 times the square root of 24x squared. And maybe this is not any more difficult for you, but a lot of you are going to forget to simplify the 24. Right? That 24 can't stay that way. It's got a perfect square in it. So now we can take that out as a 2. Comes out and multiplies. That gives us 4x times the square root of 6. Get the same thing. I just think it's a little easier to take care of that at the beginning. Maybe even as you write the problem down. All right? What would we do here? Distribute. And when I multiply the square root of 2, I have to multiply it by both of these things. What's the square root of 3 times 2? Excuse me, the square root of 2 times 3? Yes, 3 times the square root of 2. Why can't I multiply those?
Because they're irrational.
Because one's rational and one is irrational. When I multiply these two, is it okay to multiply those together? Yes, because they're both irrational. And then I get the square root of 12. Can I leave the square root of 12 that way?
No, sir.
No, because it's 4 times 3, right?
So it's 3 times the square root of 3.
So I get 3 times the square root of 2 plus 2 times the square root of 3. Can I add those two things together?
No.
No, they're not like radicals. The radicands are different. Remember, like radical expressions have the same index and the same radicand. Okay? All right? Do this one on your own. All right? What about it, Phelps?
You multiply and you get the square root of 12 minus the square root of 18. And then
Okay, that's good. You could do it that way.
2 times the square root of 3.
That's 2 times the square root of 3.
Minus 3 times the square root of 2.
3 times the square root of 2 is good. Now, one thing you could have done, maybe it saves you a little bit of time, maybe it doesn't. What's the square root of 9? 3. So when you multiply initially, you could go ahead and make that 3 times the square root of 2. I don't know if that's any easier or not. It's just another way. Did anybody do it that way? Yeah, a couple of you did. 4 of you. Perfect. All right. This one, what are we going to do? Distribute how many times?
Simplify, actually. Let's simplify first.
Twice, right?
Simplify.
Now, we could simplify first, and that would make life easier, wouldn't it? If we chose not to simplify first, we would need to multiply that times that times that, this times this. Oopsie, I did my lines wrong. And then this times that. Okay? It's much, 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 much easier in this particular problem to recognize that the square root of 9 is 3, and then we're distributing 7 times 2 minus the square root of 6.
It's a nice 7 you got there.
I love that 7 myself. Distribute that, we get 14 minus 7 times the square root of 6. immensely more easier than doing it the other way. Okay? All right? So kind of be smart when you can. This case we can't, right? So I need to multiply 6 minus the square root of 3 times 6 minus the square root of 3. That's what it means to square something. 6 times 6 is 36. It's minus 6 square roots of 3. There's another minus 6 square roots of 3. Negative times negative is positive square root of 9, which we could go ahead and write that as 3, right?
So that's 36.
So 36 plus 3 is 39. Add these two numbers together because they are like radicals. Same signs. Add and keep. Negative 12 times the square root of 3. And my stylus is not cooperating today. I actually I cut the screen protector off of this iPad thinking that it would make my stylus write better, and it has had the opposite effect. Go
New
figure.
screen protector.
All right, so that's supposed to be a
3.
3 right there, and I can't get this
Is it a
stylus to
positive?
run through. Let
Is
me
it a
move it
plus or
somewhere else. 3. There we go. Okay.
Is it a plus or minus?
Chavez. Do we know somebody named Chavez? It just elicited that kind of response immediately. Just putting the Chavez on the board, everybody awoke.
Not that Chavez.
Everybody got stirred up. Chavez. Is that Chinese?
No, it's Mexican. It's Spanish.
Mexican?
Mexican?
It's Mexican?
Only people from Mexico are Mexicans. You realize that, right? Avocados from Mexico.
Oh, yes.
All right.
Was that
Here we
last
go.
year? Was that last
I don't
year's
know.
Super Bowl?
Find the area of the rectangular throw rug.
Avocado.
The rug has a side length of this and a width of this. So if we're going to find the area, what would we do?
Multiply the 2 times together.
Multiply the length times the width. I have no idea what's going on. My stylus is not working.
Let's stay. No. Let's stay.
Just have to use my finger. 2 plus the square root of 2. All right. 8 plus the square root of 5. And then we're going to do what we just did a moment ago. 8 times 2 is 16. Plus 8 square roots of 2. Plus 2 square roots of 5. Plus
Square root of 10.
square root of 10. Can we combine any of these?
No, sir.
We cannot. That's all we can do. Of course, we need to mention that that's feet squared. All right?
We didn't do that if we didn't mention feet squared on the test. We'd get it wrong.
No. All right, there's your homework.